Hey guys, what's going on? Section 4.2, go ahead and get that ready. And then also get Desmos out, just in case we need it, because we usually will use it. Alright, we're going to solve quadratics by factoring. So we just did a little bit of factoring review, and that was, of course, the review is for how much you may have forgotten. And we will continue to keep practicing this, but this is really the cases that you need to know how to do factoring for the SOL test or exam or whatever. So there are multiple ways to solve quadratics. And some you're going to find are easier than others, and it depends on really the problem that you're given, on how convenient that the method is. So I'm going to spend a little bit of time on each of these methods, and we'll figure out which ones end up being the most used. So I'm going to try not to spend too much time on factoring, I don't believe. We're going to go through each of these steps, and then we're going to solve some problems, and then I'll just leave the rest of the problems for you to try if you would like to. So first thing is we're going to move all of our terms to one side and set the equation equal to 0. That's vital. And then after that you factor, or you take out the GCF. That's a big thing. GCF, take out the GCF first. Always see if all of your terms have something in common. That's the backwards of distributive property. You're undistributing and seeing what each term has in common. And then, let me get my highlighter back. You will take each factor and set them equal to 0, and then you will solve for each of them, and then your answer will look like a solution set. For example, x will be whatever your two answers are. Your fancy brackets, and then your answer, comma, your other answer. Usually you do them least to greatest. Quadratics will typically have two answers. Do you know why they will have two answers? Because you have x squared. Okay, quadratics, of course, are always x squared. Alright, just to keep this vocabulary going, quadratics, that means you have x squared, and that means you have two solutions, usually. Okay? Usually two solutions to look out for. Alright, let's go ahead and get started. Nothing like jumping in and doing it. Okay, some of this will seem familiar to you. We're just trying to refresh your memory. So we'll start with some purple. Okay, first thing is GCF. Well, actually, first thing was get everything to one side and have 0 on one side. And that's a pretty standard thing to do when you're trying to solve without graphing. So we got 0 over here, and then we got all my other stuff. So this one's already set up nice and neat. Okay, now do these two terms have anything in common that I can take out? X squared plus 9x. Yes, they both have what? They both have an x, at least one x. This one has two x's, this one has one x. So the greatest common item that they have is a single x. So it's going to change and look like this, since like I said, we're doing backwards distributive. We're trying to make this look like a distributive property before we did it. And then we subtract how many x's? We subtract 1x, so we're left with 1x. And then what are we left with in this term? We took out that x, and we're left with a 9. Okay? So to double check, to make sure you did it right, FOIL it back in, or distribute. X times x is x squared. X times 9 is 9x. Yep, I did it right. Okay, now we're at step 3, actually. Okay, we already had 0 on one side. Step 1, we already took out a GCF. That was step 2. Step 3 is set each factor equal to 0 and solve. So what that means is each factor, okay, that might be kind of confusing. Now in your head you need to split up factors by multiplication. So really right here I have a multiplication. I have this value times this value. So this is factor 1 and this is factor 2. Okay? So these are my two factors. So quadratics will typically have two factors because we want two answers. Yeah. So, now you're going to take each factor, set it equal to 0, and see what value, basically we want each of these factors to equal 0. So we will change our color, first of all, back to this. So this we're going to set equal to 0. And then this we're going to set equal to 0. And we can drop the parentheses. Those are not really relevant. So this value equal to 0, this value equal to 0. What we're trying to get is the value that goes through the x-axis, so that's wherever x is 0, okay? Or, well, actually, it's where y is 0, but we're making y 0. So, yes, sorry, I said that backwards at first. And we're trying to make the y 0 because that's where it intersects the x-axis. I know, it's confusing. But anyway, well, let's see if I can clear that. I don't want to move on if I'm confusing you, just in case. So, so our solutions are always on this line, right? That's where our solutions, our zeros, our x-intercepts, that's where they are on our graph, graphically, okay? So every single point on this line has a 0. Which number is 0? The first number or the second number? If I have this coordinate, it would be -2, 0. If I have this coordinate, I have -4, 0, -6, 0, -8, 0. Which value is always 0? The y value, right? Not the x value. So the y values are 0. So this is what I'm doing. I'm like treating the 0 as really a y, okay? And maybe I can kind of help you out a little bit more. I'm going to try a little experiment. I'm going to type this in the calculator. X squared plus 9x. And this is actually kind of how the calculator works. Alright, now I'm going to take the whole thing. I'm going to copy it. And then I'm going to change this to a y. Let's see. Oh, we don't get Oh, yes. Oh, man, I'm so glad I did this. Okay, so take a look. So I have this as my original from the problem, right? Equal to 0. And then if I just change it, instead of 0, I put y. Look at, yes, I get two different graphs. However, their solutions are the same. So it doesn't matter if you have a 0 or a y. Okay, this is my red equation. The red equation, they're showing straight lines because we're just looking for the solutions. We don't really care about the rest of the graph. So, but it's the same locations, right? Same locations, -9 and 0, 0, okay? But the y equation, it just shows all of the possible values that this could be instead of 0. But we're setting it equal to 0 because that's the only thing we care about. We only care about these numbers right here. It just makes everything a little bit easier in seeing only one variable instead of two variables. But as you can see, so this is the blue parabola, they have the same answer. So it's just kind of an easier way of seeing everything. And solving, it's an easier way of solving when you don't have your two variables. Okay, so now that we hopefully cleared that up, so I want to get x by itself. This is nice and easy. X is already by itself. Woo, we're done. Okay, over here, we got a -9. And x is equal to -9, and to verify that, 0 and -9 was correct. 0 and -9 are my x-intercepts. So, there you go. You can check on the graph that you are correct. Okay? And again, you can really do this by graphing as well. So, graphing, in my opinion, graphing is the easiest because Desmos does it all for you. So you can always put it in graphing. Now there will be questions where I do need you to show this factoring work. I'm not going to like push it to death. I'm not going to kill you to death with it, but you do have to know the basic factoring. Take out GCF, take both of your items, set them equal to 0, and solve and get it that way. But definitely use Desmos to check your work, because as you can see, it gives you the answer pretty quickly. Alright, so now to write this in set notation, let's take our lowest number, -9, put that first, and then 0, and that's our solutions, okay? Alright, let's go ahead and do number 2, so let's take a look at this. We got 0 already, so step 1 is all good. Let's take out some GCF. We've got this, both of them can take out a 4 and an x. So we'll take out a 4x. What's left here is just an x. What's left here? divide, so that remember to get what's left, you divide. 8 divided by 4 is 2. And then we took out the x already, so we don't have any leftover x's in that set. Here are my two factors. So wherever the multiplication is, because remember when you look for factors, like factors of 9 are 3 and 3. The reason they're factors is because we multiply them to get 9. So that's the same idea. It just we have terms with x, and we break it up where they are multiplied. So we're going to take both, set them equal to 0. So for x equals 0 and x minus 2 equals 0. Divide by 4, and 0 divided by 4 is just 0. And then add 2, and x is equal to 2, making our solution set 0 and 2. Nice and easy, super fast, right? Yeah. Alright, I think you could possibly handle some of these. No. Oh, yeah, never mind. I was going to let you try, but it changes rather quickly on us, doesn't it? Alright, one other thing we can do is we have just a review of this last one. This next one is like one of these. When you have a difference of squares, that can like, kind of throw you off. So this next one is an example of that, even though they don't have a 4 or an x in common. However, they can both be square rooted. Okay? So remember that. So this one can be a square root, and this one can be a square root. So the two terms will be this variable, or the square root of that variable, which is x, and then the square root of 4 is 2 and 2. And to bring out your negative, you have to have different signs. So plus, minus. This is one you just got to engrave in your brain every time you see it. X squared minus 4 is really x plus 2 times x minus 2. Alright, so then we've got our two factors rather quickly. And really, there's no other shortcut to do this. Or, yeah, you could do Desmos, x squared minus 4. Let's set that up. Oh, let's just do this part. And your solutions are negative 2 and 2. So boom, you could get that in the calculator as well. The solution to this one, again, this is not my solution, or 2 is not my solution for this one. Negative 2 is my solution. So moving that over. So negative 2 is the solution to this factor, to the plus 2. Okay, because it's just getting this x by itself, you're going to have the opposite answer. Making our answer negative 2, 2. Okay, this next one, so looking at my numbers, do I have anything in common? 9 and 25. 9 has factors of 3, 25 has factors of 5. And that's about it. No, 3 and 5 we can't. However, they can be square rooted like this one. So square root, both. And this always becomes a binomial, or a, well, yeah. So, square root of 9x squared. Square root of 9, first of all, is 3. Square root of x squared is x. And then the same thing over here. So when you have two items, you've got to square root both. Okay, if this was a plain old x, we couldn't do this. Because we can't take the square root, we can't simplify square root of x. So it wouldn't work. Because it's squared, I can square root it. Okay, the square root of 25 is 5, so we put that there. And then I want both of my signs different. So that way that'll result in getting my negative. Set that equal to 0. And now we're ready to set each factor. So right here is where the multiplication is, so that's where I split it up. Set both of them equal to 0. Alright, add 5. And then divide by 3. And we get a fraction. So we get 5/3. And Divide by 3 again. Now we get negative 5/3. So this happens often, okay? We get the same value. The two answers are the same except one's positive, one's negative. Another way you can write this answer, if you so wish, is put plus minus 5/3. And that is acceptable as well. Okay? And we're going to get more into this plus minus here this chapter. So we're going to be using that more. That just means all that indicates is that there are two answers. The positive value and the negative value are both the solutions. Okay? Alright, so we've got some even different ones. We're going to keep doing some together and then not break up the flow. Alright, now I have a trinomial. Okay, so remember this as before. We're going to do the factor tree or your factor box, square, whatever, if you like to use that. So these are the two values I used. The last one goes first, so positive 21. And the one here goes here. If you don't know what I'm doing, you skipped a video. You need to go back and watch the video before this one. So I'm going to go pretty quickly through this. So I need to multiply this column. I'm multiplying two terms to get 21, and then I add the same two terms and try to get negative 10. So factors of 21 are, of course, 1 times 21, no 2, 3, 3 times 7, and I believe that's it. So which values does it look like I'm going to be able to add and get me a negative 10? Now to get a negative number, I'm going to have to go ahead and make all these negative. Because that's the only way. Only way I can have a positive value when multiplied, but a negative value when added is if they're both negative numbers. So which values do I add to get negative 10? Clearly, that's this one. Negative 3 plus negative 7 will give me the negative 10. So this is the pair of factors that I know I need. So you just go ahead and set it up like the previous ones, like this, and then you just take your variable, and then you plug both of these in. Keep the signs the way that they are. Minus 3, minus 7. It's really easy when it's 1 here and then equal to 3. The answer is really just the opposite. So if you want to, if you understand that your factor is going to be the opposite of this number, you could just skip that setting it equal to 0 part and say, alright, I know that this value must be a what? A 3. In order to equal 0. 3 minus 3 equals 0. That's my goal. I'm trying to get each factor equal to 0. So you can just imagine, right? 3 would make the 0, and then in this case, x would equal 7 to make this set 0. And then my answers would be 3 and 7. Ding, ding, ding. Yay! Okay. Number 6. So we've got 0, so step 1 is good, and again your steps are back up here. Go by these steps, don't forget about them. Alright, what do I have here? I've got a trinomial like as before. However, taking a quick look at my coefficients, 2, 2, or negative 2 really, and negative 24. What can I do? Yep, couldn't do that on this one. I had a 1, a 10, and a 21. They did not have any common factors, GCF. However, here we do. We have a GCF of 2. So we're going to go ahead and take that out. Be careful and watch out for that first. So divide everything by 2 and take that out. Alright, now this is like what I had right here. So you got to watch out for that. When I have a trinomial where the coefficient is a quadratic, or the a is 1, I need to do my factor tree. So this section right here. Alright, last number goes first. And then my b number is negative 1. So what can I multiply and get negative 12? I can do 1, and I'm going to start without my signs. I know 1 times 12. I know 2 times 6. And I know 3 times 4. Okay? So I've got these possible scenarios. Now I know to get this negative, one of them is going to be a different sign. So now I'm looking really for a difference. Okay, which one of them will have a difference of negative 1? Because I know that they're going to actually be subtracted because one of them is going to be negative. So in this case, looks like my 3 and my 4, okay? I'm pretty sure it's going to be 3 and 4. Now, which one is it? Is it 3 plus negative 4, or is it negative 3 plus 4? Which one will give me, because again, this column is multiplication, this column I'm adding whatever pair that I think it is. 3 plus negative 4, yeah, that would give me a negative 1. Negative 3 plus 4, no, that would be positive 1. So it's not that one, it is this one. Alright, so I just replaced this whole quadratic, because the 2 was before that, and it's okay, but I still got to leave it there. And then my factors I got from here are x plus 3 and x minus 4. Alright, now this is a little bit interesting, and I'm pointing this out because later it'll be important. I have now 3 multiplications, so it might seem like I have 3 factors, and no, not necessarily, since it's still a quadratic, I'm still really going to have 2, but this is going to be important later because you will have 3 later on when we get into the next chapter. We could have another term, this term right here could have an x in it. So I don't want you to just write it off, okay? So what we're doing really is saying 2 equals 0 because the next step is to set everything equal to 0, but that's a false statement. So we really just ignore this right now. Later, you don't want to ignore that if it has an x. So this value, x will equal the opposite, negative 3. Right here, x will equal the opposite, which is positive 4. So my solutions are negative 3 and 4. Alright. Hopefully you're doing okay with this. Let me assign you some problems. Actually, before I assign you some problems, let me show you one more thing. I'm not going to worry about these two. But if you look on the next page to practice this stuff, these are set up different, as in 0 is not by itself, like these ones were. 0 was already by itself. So you have an extra step here, and I'm just going to go ahead and show you that one step, and then you can practice it. So, well, I don't want to do that first. So we want 0, and since this is positive, I like to keep the leading coefficient positive if possible. So I'm going to move this over here, and I want 0. So the opposite of 5x, to be able to move it to the other side, would be to minus it to the other side. Then some people are still doing some algebra mistakes here. You cannot subtract these. This is x squared, and this is x. You can't do that. So you have to leave them to x squared minus 5x equals 0. Okay? Now you can do GCF. Okay? You can take something out, equal to 0, and continue from there. Okay? Over here, same idea. I got most of my items are over here. Let's subtract x squared. And I'm going to subtract it from this term because they are like terms. I can actually subtract them. So 7x squared minus x squared, that's really a 1. So 7 minus 1 is 6x squared plus 8x equals, this out here became a 0. So you can do another GCF here on this one. And I'll leave you to do that. So hopefully you get the idea that you can just take all these. I would just move everything from this side to this side. In this case, same thing. I would actually move this over here because I don't really like having a negative leading coefficient. So move everything to the left on that one. And I want you to try these and then see the answers. Some of these I don't want you to worry about. Let's see if number 7, if we can get it in the calculator. I'm just going to go ahead and do it because I really don't want to get into all this mess. Because some of these can be messy. 3x squared minus 13x. 3x squared minus 13x minus 30. And I think we can get our solutions this way. So for these like messy ones, I'll let you do them in the calculator. The reason it's messy is because this number is not a 1, the coefficient of x squared. 3x squared minus 13. x minus 30 equals 0. Alright, we just click here and say, alright, that answer and that answer. So I know my solutions are negative 1.6 repeating as a decimal. Can you, and I think maybe you can do this now. Before you were not able to do this. You can type in your decimal and then, well, okay, and then you look for this thing right here to show up, and it can take your decimal and put it into a, well, into a fraction. That's not exactly what I wanted. Do more, maybe. There we go. Okay, so that's what it is. You have to type a lot more, and then it recognizes that it's a repeating decimal, and it gives you this. So when you get that, again, what I did is I took, okay, what is this as a nice fraction? You can put this as the answer, negative 1.6 repeating, but you got to put that repeat bar. So negative 1.6 repeating, so you have to have that bar. Otherwise, I'm going to take points off. Okay. And this one I'm going to mark as Desmos. And the other answer was 6, right? Or you can change that repeating decimal to a fraction if you like fractions better. Negative 5/3 and 6. Okay. Alright. So that's what I would do on those ones if you're not getting nice, pretty easy factors like this. Okay? Alright, go ahead and pause the video and try any of these problems that you want, as much practice as you think you may need, up to number 18, and stop there, and then when you're ready, press play to see the results. Alright, good luck. Alright, here we go with some answers. So number 8, if you do that in Desmos, that's fine. You get negative 4/3 and 1/2, or this is 1 1/3. Negative 1 1/3. Number 9, 0 and 5/2. Number 10, and that's the same thing as 2 1/2. Number 10 is negative 4/3 and 0. Number 11 is negative 7 and positive 7, or plus minus 7. Number 12, plus and minus 9/2. Number 13, negative 10 and 8. Number 14 is negative 5. This one kind of stood out to me because it had had only one solution instead of 2. I want to show you why. So it has to do with the graph. So x squared plus 10x plus 25 came out to 2 factors of positive 5, making both of their results for the solutions negative 5 for both. What does that look like on the graph? So if you graph this with the equal to 0, you get that one line like we saw before. But if we change it to a y, the actual parabola shows up, and what it does is the vertex of that parabola hits right there at negative 5. And that will be a case where a quadratic will have only one solution, and that's because the vertex sits on it. So it really counts that scooping down and hitting that number and going immediately back up, it counts that as 2 solutions. And so you will see that on quadratics, okay, that's what the graph, that's what's happening on the graph in that case. That's where the vertex is hitting at that number. And it does not go below or above the x-axis. It just hits right at that number, that intercept. Number 15, negative 5 and 13. Number 16, negative 3 and negative 8. Number 17, negative 3 and 7/2. That's the same thing as 3 1/2. And 18 must do the same thing. It gets 3/2 as the solution, so it probably scoops down. I didn't check it, but it would probably scoop down as well. And again, to get that, you just change this from a 0 to a y. Okay? And that's the actual graph of this. The 0, when it's equal to 0, that is just showing us the solution. But really, the actual graph of this equation is when you have it equal to y. Okay, we'll see you on the next one. All right. Factoring, we made it, yay.